Okay, can everyone see that?
Yes.
Yep, okay, great. Okay, well, thank you for having me here. So yeah, my presentation is on model integration at the watershed scale, especially for FloodMAR analysis. So just a little bit of context for this presentation. It's going to focus on the models that we're using for FloodMAR and the integration of those models. Everything that's been done so far on that vein has been for the Merced River Reconnaissance Study. So I'll be using that study as our kind of template for the modeling. I won't go too much into the study itself, just focusing on at least the models that we're using there. It's not just a FloodMAR study, it's also a climate change vulnerability analysis as well, and I'll get into a little bit of the details of that. So let me go ahead. To kind of put the modeling into context of the DDBAR FloodMAR activities, let me see if I can get my pointer. Okay, I guess we'll go with that. There we go. So the integrated watershed modeling kind of fits into this overall package of watershed studies that the department is working on, but there's two other areas that the department is trying to push forward with as well. Guidance documentation and pilot projects and studies. These other two haven't really taken off quite yet, but we're trying to move those forward as well. Mostly, most of the work has been focused on watershed studies, and that's where the integrated watershed modeling fits in. But we think this kind of package here is what will help push forward FloodMAR as we develop these watershed studies and the watershed modeling. Information of that can help feed into the guidance documentation. One of the ways that we think that'll happen is for the Merced study, we're putting on a series of technical memos. As we move through the study, we've put out our plan of study a couple months ago, and we're working on a model integration memo actually that talks all about all the models used, how they were set up, integrated, all that. And then as we continue through the study and get results from all the different FloodMAR scenarios that we model, we'll put memos out for that. And we're kind of thinking that those memos and other guidance documentation can help other departments, locals, whoever, if they want to start doing their own FloodMAR studies. And at the same time, as the guidance documentation comes out, that can maybe help inform other watershed studies or other integrated modeling. And then on the pilot project side, we're looking to try to implement some pilot projects to test out some of the things that we see through the watershed studies. For the Merced River, for example, we're trying to see if maybe we can try to get a Merced pilot going that uses a lot of the information that we've developed through the Merced study. And as pilot projects come online and we start to learn some real world benefits, impacts, information, that information can be used to help inform more guidance and to better improve the models as well. So this is kind of our FloodMAR activity package that we're trying to move forward with right now. Some goals and expectations of the Merced study and the integrated FloodMAR modeling overall. Right now, we kind of see it all as a proof of concept. I think we've said this quite a bit. FloodMAR itself has been happening for a long time in the state, but it's always been at a very small scale, individual farmers. DDBAR with this study is looking to scale it up to an entire watershed, looking at a major reservoir, multiple streams, a large groundwater system, irrigation network. So we're hoping that this is kind of a proof of concept that FloodMAR can be scaled up to where you can get a lot of benefits and multiple benefits from that: flood, water supply, ecosystem, groundwater, all of that. Another goal for this is the integrated part of the integrated watershed modeling. Most studies, at least the ones that I've been on, usually just kind of focus on one sector or one area of water resources, typically flood in my case. With this study, we're trying to integrate all of the aspects of water resources management in a watershed. So flood, water supply operations, irrigation, ecosystem, and both the surface water and groundwater, all of that trying to get integrated. And I think as I go through the slides, that'll become a little more evident. As I said about kind of the guidance document, is we're hoping that this will be a template for future studies and projects. So we're documenting the whole process and we'll be putting those out. And kind of one expectation out of this right now is this is all reconnaissance level modeling. We're calling it a reconnaissance study. We are trying to be as detailed as we can be and put as much information into the models, and some are very detailed. some maybe not as much. But at the end of the day, at least for now, we're just kind of going with this expectation that it's a reconnaissance level. So if you see areas where we're lacking things, we're making notes of that. We're going to put that as maybe next steps or future improvements, but that's kind of where we're at right now. So before I get into the models, I just want to touch on the hydrology that we're using in this study. It's a paleoclimatic reconstructed hydrology. What does that mean? The DBR climate change team has been developing this, and they've used it on a few other studies. It's kind of a recreated historic simulation of watershed runoff. They use gauge data from the last 50 years, tree ring data to kind of reconstruct this long time series of hydrology. For our study, we're just using the last 100 years of that from the year 1900 to 1999. The nice thing about this hydrology is that it can be perturbed for different future climate scenarios very easily. Very early on in the project, we wanted to incorporate climate change, and we looked at all the different kinds of climate change hydrologies the state and others have used. And this was something that had been recently done with the climate change program here in DWR. And it's all part of a decision scaling bottom-up approach, if you've heard those terms before. It's kind of a way to look at a broad spectrum of future potential climate scenarios to get a kind of a better handle on the uncertainty of future climate change. So in our study, we're looking at 30 climate scenarios. We're looking at increases of temperature from 0 to 4 degrees Celsius and changes in mean annual precipitation from negative 20% to plus 30%. So basically what that looks like is here on this kind of spectrum of change in temperature and change of precipitation. Each of these dots is basically a set of model runs, 100 years worth of continuous model data through all of our models. And then we can generate things like here, what we call a system response curve, where we can see how the system responds to all these different future climate change. There's a lot more information on this hydrology and the decision scaling, and that's probably a good topic for another presentation in the future. I don't know if Romain's on, but I'll volunteer him to present that in the future. So before we get into the good stuff, into the modeling, there was a poll question just to kind of gauge everyone's level of knowledge and experience with modeling. So there's 5 options here. There we go. So top one, I know Fortran, if you're an expert. Advanced, you build and run your own. Intermediate, you run them. If you're a novice, sometimes you use Excel. And if you're like me before coffee, how do I turn on my computer? Let's give that a little bit. No. Oh, wait, I see one person on none. Okay, give it a few more seconds. There's a few more people still voting. Pretty good spread.
I'm going to end it and share, David.
Okay.
Just so everybody can see who's
all right.
Everybody's level. It's really a nice mix.
So yes, very nice mix. A lot more experts than I expected, but that's all right. Okay. So we'll go ahead and move on. There we go. Okay, so into the models and the model integration for a FloodMAR analysis. This is all based on the Merced study, as I said. So this is our model integration flow chart. And at first glance, it probably looks pretty confusing. And even after about 10 glances, it's still pretty confusing. But kind of the main thing from here is there's a lot of different models to be able to model all the different aspects of the watershed and all the different areas of water resources management. And there's a lot of information moving from models to models. And sometimes there's information moving back and forth between the models. And we even have some kind of iterative loops between the models. So I'm going to try to break this down and go through step by step. And hopefully this will all make some sense. So let's start with the San Joaquin River kind of Central Valley here. We've got City of Merced down here. Or, I'm sorry, City of Fresno down here. City of Merced right here. Stockton, the Delta. If anyone's familiar, Los Banos, that's where I'm from right there. And this is our study area for the Merced study. So even though we do talk about watershed scale modeling, I've kind of zoomed this out because for FloodMAR analysis, we do have to go beyond our study area and beyond the watershed scale for two reasons. First one is for our groundwater modeling. This is our groundwater model. We call it FM2SIM. It is a clipped up version of the state's C2VSIM fine grid model. It's been clipped to the Merced subbasin, which is within our study area, but then also the surrounding subbasins as well. And we figured out pretty early on that for groundwater, it doesn't really stick to what the watershed is. The subbasins are all interconnected, water's moving back and forth. What's happening in one subbasin can affect another one, especially when we start to get into FloodMAR. As we start to recharge in our Merced subbasin, that's going to have impacts on the other subbasins around it. And with that 100 years of hydrology, what's happening in those surrounding subbasins is going to have an effect on the Merced subbasin. So we do need to go out beyond watershed scale for this aspect of it. So to provide inputs for that watershed model, we're using a CalLIGHT system operations model. So the CalLIGHT model, and this is one I need a little bit of help on. It's co-developed by the Department and Reclamation, and it simulates coordinated operations of the intertide Central Valley system. So state water operations, Central Valley project operations. This model, I'm only showing a very small portion of the CalLIGHT model, just kind of pertaining to the San Joaquin here, but it's really a statewide model. The inputs from the reservoirs, the outflows, irrigations, all that is going through the CalLIGHT model, and that provides information into our groundwater model for the boundary areas. Another aspect of the CalLIGHT model that's important for FloodMAR is that it can look at delta conditions. And the delta conditions are important because for FloodMAR, we do FloodMAR, at least in the modeling, we do FloodMAR operations when the delta is in excess conditions. If the delta is in balanced or restricted conditions, we cut off FloodMAR and don't do any FloodMAR operations. So the CalLIGHT model can tell us the delta conditions. So to provide information to the CalLIGHT model, we have our watershed rainfall runoff models. We're using SAC-SMA. This is a model being used by the DWR climate change team. It was used for the decision scaling hydrology. Like I said, Romain Menley can give tons more information on this modeling from our climate change program. But that model provides our inflows into the reservoirs for our boundaries on the CalLIGHT model. So now we'll zoom into our study area and look at the more focused watershed modeling. So SAC-SMA again is providing our watershed runoff for the Merced upper watershed here into our reservoir, which is Lake McClure. We have a reservoir operations model for Lake McClure. We're using ResSim for that model. This is a model from Merced Irrigation District. It was kind of more of a real-time model. We took that model and we put a lot of work into getting water supply operations, flood operations, snowmelt, minimum street flow requirements. We got a lot of input from their operation manuals from Merced Irrigation District on how they really operate this reservoir, because we were going to be operating this for 100 years of hydrology continuous, and we want to make sure we get all those aspects in there. And this model runs on a 3-hour time step. So it's a very detailed model of reservoir operations. We also have a number of smaller watersheds in our study area. So we have another watershed runoff model. In this case, we're using HEC HMS. This is also a Merced Irrigation District model. There's a number of creeks through here and a couple of flood control reservoirs. I'll name these ones. We have Burns Reservoir, Bear, Owens, and Mariposa Reservoir. And those are 4 major creeks. And these creeks, one of them, Bear, runs right through the city of Merced. Some of these other creeks run kind of around the city of Merced. So there's issues of flood control due to these creeks, and there's potential for FloodMAR. So we're not just looking at the Merced River for FloodMAR, we're also going to be looking at these creeks. So we need this model as well. Now, outputs from these models go into the Merced subbasin part of our groundwater operations model. And then some of the information from our groundwater operations model actually goes back to our ResSim model. This is where we got that arrow going both ways. Things like irrigation demands come out of the groundwater model and go to our reservoir operations model. The reservoir operations model takes that time series demands. It looks at the inflows, and there's a bunch of calculations that go into the water supply component, and then it'll try to meet those demands the best it can according to the manuals and how MID meets the irrigation demands downstream. So all this right now is kind of set up to do our baseline analysis and also climate change analysis. We can run all the different climate change hydrology through the upper watershed model and down through all these models. But for FloodMAR, there's still one more model that we need to be able to do the FloodMAR analysis, and that is our recharge optimization model. In this case, we're using GRAT. It's a groundwater recharge assessment tool. And I'm going to go into a little more detail on that model. We'll zoom in to the lower part of the basin here. So the GRAT is a really cool model. These are all really cool models, but this one especially for recharge optimization. I'm gonna try to make sure I get this right. So this model uses information like the conveyance network, the conveyance capacity. So here in the purple lines, this is the MID conveyance network through the Merced subbasin here. And then the bluish green is the district boundary for MID. So that's an input into the GRAT model. It looks at things like bottlenecks, the capacities of laterals, where it goes spatially. And then it uses other information such as the SAGB index. And that is, for those that have heard it before, it's a soil agricultural groundwater banking index. And it's used to look at this. It's a suitability index for groundwater recharge. So they rank the soils from excellent down all the way to very poor for suitability for recharge. So for our study, we're looking at soils that are ranked as excellent, good, and moderately good. And you can see we've got kind of a mix of those three rankings throughout our system here. Another input is land IQ. This is crop use throughout the subbasin here. And there's certain crops that are that can work with FloodMAR operations and recharge. Here's a list of the crops here. We have alfalfa, almonds, cotton, grapes, idle lands. So there's nothing going on. They're idle at the time. Pistachios, potatoes, tomatoes, and walnuts. So we have all that information also spatially put into this GRAT model. So the GRAT model takes all those different layers of information, and it takes FloodMAR water that comes out of both our reservoir model and our HMS models, and we call that FloodMAR wafer, water that's available for recharge. And based on all that information, GRAT then has a listing of potential recharge sites throughout the basin. And these are all ranked on how good they are for recharge. And that FloodMAR wafer works its way through the GRAT model. It distributes the wafer recharge as best it can. If there's any water that's unused due to bottlenecks or we've just recharged too much or whatever, that water would then go back to our other models as flow that would continue downstream. A couple key things with the GRAT, what it provides a spatial distribution of where the recharge happens. With GRAT, now we know recharge is happening here or here or here. It provides a temporal distribution of when that recharge happens, how long that recharge is happening. Is it happening for a week, for a month, for a couple days? How long do we need to wait between recharges? Certain crops can only take, such as almonds, can only take recharge water for a short amount of time before we need to let them dry out again, and then we can reapply again. So GRAT can provide that kind of information. And it provides a volume distribution of how much recharge can happen by field throughout our entire subbasin. So all that information then eventually gets carried into our groundwater model. So then the groundwater model can take that recharge and we can see what happens with that recharge water and throughout the rest of the subbasins here. Where's that water going? Is it percolating deep? Is it potentially going back to the rivers? Is it going into an adjacent subbasin? That's what we can get from our groundwater model. And that's kind of an important thing about us having to go out beyond our study area for the groundwater model. So a couple more models now, moving on downstream past the recharge and looking at flood impacts. It's FloodMAR. So one of the ideas is we're diverting flood flows. And part of the climate change vulnerability analysis is to also look at flood flows. So we'll look at, again, our reservoir operations model for the Merced River and our rainfall runoff models for the creeks. And information from that models goes into our stream flow or hydraulic models. In this case, we're using HEC RAS. We have two hydraulic models, one for the Merced River and then another one for the creeks. The Merced River one is scoped out pretty well. We used information from MID, from the department's CV Fed program, some information from USGS. try to make sure our extents went far enough out to really capture those potentially large future climate change flows. For our creeks model, we're a little bit more limited there. We are able to get a couple of the creeks, but there was just a limit to what information we had available. But we do still have the city of Merced, which we think is kind of the important part to at least have, because then we can look at flood damages. So information from our RAS models then goes into our flood damage model. We're using HCC FIA, and here the dots are the structure inventories throughout these two areas that we're modeling, and we can model flood damages. So information like stream flow, stage, inundation depths all come out from the RAS models and then go into our flood damage models. So that's a trip through all the models. I'm just going to touch on a little bit of model integration issues that have come up that we've been having to deal with as we try to integrate all these models together. Typically, a lot of these models were not really meant to be integrated together, or at least not so many all at once. So a lot of issues have come up that we're kind of working through. File formats is one. Some models use text files, other ones use Excel spreadsheets. A lot of the HCC models use DSS. So we've had to work through developing scripts on ways to move information from one format to another to be able to use in one model and then maybe back again. The time steps are different for all these models. Some of them are on hourly, some are daily, and some are monthly. So as we move that information back and forth, we'll have to aggregate it up or disaggregate it down as we move it between. Run times, some of the models run really fast, a couple hours, some take as many as a few days. So we just have to take that into account as we start to go through the whole process of modeling and sequencing out. And that's the next step, is model sequencing. With information moving back and forth through a lot of models, we just have to be very careful as we set models up and sequence them and move data between them. And in some places we have iterative loops, so information has to come from one model back to another. That's something we have to deal with. Quality control, we're trying to be as careful as we can as we QC all these models. It's a lot of models, a lot of information, a lot of data. So QC is very important. And that last part, data generation and then analysis of results and metrics. With 9 different models running 100 years, 30 climate scenarios, we're looking to do up to 9 FloodMAR scenarios. We're going to generate a lot of data out of all of this modeling. That's why I say here, humongous data. We need to make sense of all that and figure out a way to present it so it means something. There's a lot of results that are great, but certain people may be only interested in certain results. So we're working right now, and I'll say Karen Dev Singh, who's also on the team, is doing a great job on this, on trying to distill down all those model outputs into a handful of really important metrics and results to track, so that we can make insightful decisions or conclusions out of all this modeling. So that is everything. I just wanted to thank the FloodMAR team. There is a big team of folks working on this, of DWR staff and consultants. It's a great team. Everyone's contributing a lot to all the models. If you have real detailed questions, a lot of these people can also help. They know more about the models than I do. So I just really want to thank them all. And that is all I have. I hope that all made sense.
Great, thanks, David, for the journey through the models. It's been great to hear how they all fit and link together. So I'm going to check with Jenny to see if there are any questions on the chat, and also if anyone wants to use the hand raise to ask questions or make comments through the participants panel. Jenny,
yeah,
anything?
Thanks, David. Thanks, Ari. Yeah, there's a couple questions, and a few of our project team members have been helping to answer them, but I'll still let you know what the questions were, David. The first question was, with the recharge model, do you assume that all land that could be recharged is, or do you assume a certain percentage of landowners might not be interested in participating?
For right now, we would assume that all landowners would be available. In reality, who knows? They probably wouldn't. But for the purposes of this study and the recon, we're not going to get into that. We'll talk about that as being a potential barrier to implementing FloodMAR is that you do need to get landowner participation. But without knowing what that could be like, we'll just assume that all landowners are available to participate for now.
Great, thanks. Another question on forecasting. How can forecasts be incorporated into the process? Would 10-day reservoir volume inflows be a good target for improving forecasting or longer times?
Great question, Mike. We're actually starting to think about that in our level 2. So just a quick description on the study. We're looking at 3 levels of FloodMAR implementation. What we call our level 1 is just existing infrastructure, existing operations, and trying to skim whatever FloodMAR we can off of that. But then our level 2 would look into reservoir reoperations. And one of the things that we want to look into is FIRO, forecast informed reservoir operations. We've just barely looked into it. We've done a few just simple preliminary runs. I think we looked at like a 10 and 14 day forecast just to see what would happen. But we're in the process of developing it, and maybe it would be good to have Mike kind of involved in that actually, in some of those discussions. But yeah, that's upcoming.
Great, thanks. Do we have results that we can share, or our schedule, at least for providing results?
We are close to having level 1 results. Things have been moving pretty slow lately with COVID kind of keeping everyone home. It has made things a little bit harder, unfortunately, to have the whole team coordinate. We are working on level 1 right now. We have some preliminary results through like the reservoir models. We have pretty much finished all of our baseline modeling. We're going to start working on our baseline TM and try to get that out late fall, early winter, hopefully. The schedule is a little bit in flux at the moment. The general schedule is you want to have the baseline TM, which is the climate change analysis, like I said, by maybe late fall, winter. Our level 1 TM results by end of winter, level 2 sometime in the maybe spring of next year, and level 3, which builds on top of level 2 reservoir reop with infrastructure, new or expanded infrastructure, maybe by end of summer next year. That's kind of our general schedule now. Yeah, we're hoping to have some results out in the next few months, at least for level 1.
Great, thanks. Are there gaps that can be solved with future research?
I'm sure there is. I think water quality is probably the biggest gap we have in this study. We really don't have any information for water quality as far as it pertains to FloodMAR. I know that was kind of one of the big things through the R&D program or in the RAC. We don't have any models. We don't have much information. So that's probably a big gap that we need to work on. Looking into permitting, we'll look into that a little bit and talk a little bit about it, but that's something I think we kind of need to work through, and that's probably something beyond the Merced study. It's just kind of a big FloodMAR thing is permitting. I'd say water quality is probably the big gap that we'll need to address eventually.
Great, thanks. There's a lot of questions, so a lot of interest here. I'm gonna jump around a little bit.
Jenny, there's just a 1 hand raise, so
okay.
maybe we can let Mark Strudley, I'm hoping I'm saying your name right. Looks like you have a hand raise if you want to ask a question.
Yeah, hi, am I unmuted okay now?
You're good, yep.
Okay, thank you. David, really interesting talk, really interesting modeling work. I have a 2-part question for you.
Yep.
The first part is related to kind of modeling philosophy. You have a really, as you explained in some of your earlier slides, you have a really complicated model, right? Each little submodel has their own set of equations and their own set of tuning parameters. Do you expect just to tease out basic opportunities and behaviors from this model, or how are you going, or are you going for magnitudes? And if so, how are you going to tune all those different parameters? You probably have dozens of them. I'll let you get to that first, and I have one follow-up question that's related, if that's okay.
Okay, yeah, I guess this goes back to my early expectation slide of this is a recon study, so we're just looking more at magnitudes. We're not saying or we're not going to say, this is what you would get. We're kind of more of, this is the ballpark of what we think we can get through FloodMAR on the Merced subbasin. As it moves into hopefully a pilot project, then maybe we can kind of see some real world results to maybe go back and compare it to the models. And as it moved into like a feasibility study or implementation, I'm sure, yeah, more work would need to be done to calibrate and refine these models. But for now, it's more that recon, just proof of concept. Is there something out there? What can we expect magnitude wise? That's kind of where the study's at right now.
Okay, and we have interest in pursuing a pilot project under FloodMAR in one of our own systems, and we're initially thinking of kind of targeted field studies and measurements and analyses, a little bit of modeling, but kind of one-dimensional modeling, perhaps point-based. And you, I guess, I don't know what choices you had early on, but you clearly went in the direction of probably trying to get the same types of answers as we're interested in, but you went for the comprehensive modeling approach. And I'm wondering what benefits and restrictions you see out of both methods trying to arrive at kind of the same types of answers for recharge opportunities.
That's kind of a hard one to answer. I think the process has been very fluid. When we started this study, we started with I think 2 models. We knew we were going to look at reservoir operations, and we knew we needed to look at watershed runoff because we were going to look at climate change. So we started there. And then we knew we wanted to look at downstream flood impacts because it's flood marsh. So we got the RAS models. We knew we needed to do recharge. So then we needed a groundwater model. And then from there, it just kind of kept building as we started looking at the inputs and what we wanted to do and how we wanted to look at all the different potential benefits and impacts of FloodMAR. It's not all just benefits. There could be some impacts as well, and we want to measure those. More and more models kind of came online, or a need for more models came online. I will say the scope of the study probably just kept growing. I think we've gotten to the point where we've stopped growing the scope, hopefully. I guess it really is what you're trying to do. For us, we wanted to really kind of, in the beginning, we just wanted to do this proof of concept FloodMAR, and then the scope kind of grew. It's been about a year we've been working on this now, or maybe longer. The scope of it grew to this kind of more watershed-based approach, especially when we started getting into the climate change aspects of it. So I don't know if that really answers your question, but maybe we should have a kind of a more in-depth discussion offline sometime.
Yeah, no, it was a tough question with actually a myriad, set of answers. But yeah, I would enjoy talking with you more about this and our approach and how they both can be used.
Yeah, I think there's a few people from the FloodMAR team that'd be interested to have a discussion with you, especially if you are working on a pilot project. We're always looking to see if we can partner with people on pilots and get whatever information we can, because any more information is always helpful. Usually.
Yeah, much obliged. Nice talk.
Thank you.
Arrate, are there any other hand raised? I have my chat window open in front of the participants.
Yeah. No other hand raises, but I've seen that there's some additional questions that have been streaming in. So if you want to highlight some of them.
Yeah, David, can you speak to what seasons or months we're looking at for the recharge model?
Yeah, so for the FloodMAR aspect, we're keeping it at least in level 1 between the months of November and March. We're typically trying to stay out of the irrigation season for MID. Irrigation usually starts around in March, but the month of March isn't too much irrigation. It's really April that they tend to ramp up. And then end of October is when they cut off their irrigation. So just a little bit of simplicity's sake, and other factors, delta conditions, available water. Since it's FloodMAR, the window really ended up being November through March. But as a whole, for baseline and everything, we do run the groundwater model and all the models year round for that 100 years of hydrology.
Thanks. And can you speak to how much water can potentially be recharged? What are we learning?
Oh, I don't know if I should say some numbers or not. We do have some preliminary results, not final. Just want to make that clear. For our level 1 analysis. So just to talk a little bit about our level 1. At level 1, we're looking at 3 scenarios within level 1. Our first one we call level 1 initial. It's kind of a very simple, we think, simple, basic, implementable version of FloodMAR, where we're using the State Water Resource Control Board guidelines of the 90th daily percentile, up to 20% of total flow. The December for them is December, or for that it's December through March timeframe. We're only using the canal for recharge. The canal system, it's an unlined system for the most part, and it has a pretty good seepage rate to it. So we're just filling the canal, let that seep, keep filling the canal, let it seep, no on-farm at all to kind of keep that aspect out of it. So for the whole 100 years, with all those limitations, delta conditions is another limitation on there. We do that delta conditions check. For the 100 years in a current climate scenario, it was 1.4-ish, 1.4 million acre feet of recharge over 100 years. So that averages out to about 14,000 acre feet a year. Not a ton of FloodMAR, but that is a very, very constrained scenario. We expect in our other scenarios, we just got some results on our level 1 intermediate that loosens up some of the stuff from the initial and does on-farm recharge. We were looking at about 3 to 4 times the amount of FloodMAR. But that needs to go through the GRAT. For the initial one, since it's just canal, no GRAT involved. For the other ones, we'll need to run it through GRAT to see if that water can actually be conveyed and recharged. So those are kind of the numbers we're seeing. I don't want to go too far into the numbers right now because we're still at preliminary stages and they may change, and I don't want someone to grab a number and run with it. But hopefully in the next couple months, we'll have concrete numbers. How's that for a very vague answer?
Would you mind recapping what the various levels of the analysis are?
Sure. So level 1 is existing infrastructure, existing operations. So we just try to work FloodMAR around what's currently in the MID Merced subbasin. Like I said, they in irrigation October. So we would start FloodMAR diversions in November and we would end them in March. We use the conveyance network, the ag lands, don't touch the reservoir at all. Level 2 then would look at reoperating the reservoir. We're kicking around a few ideas. I think, like I mentioned earlier with Mike, FIRO is one idea. Another one is trying to move a lot of storage out of the reservoir and into the ground to really open up a lot of flood space. Some kind of conjunctive use thing there, but we've just started working on those ideas. Level 3 builds on top of the reservoir reop, looking at new or expanded infrastructure. So here, one of the things that popped out early on from the GRAT model actually is that there's some bottlenecks within the existing conveyance system, some gates or laterals that are constrained. And if we could just open up some of those bottlenecks, we could get more water out to other areas that could take it. So that would be kind of an expanded infrastructure for level 3, a pretty simple one. Something bigger would be like expanding the whole conveyance system. The main canal diversion for MID is about 1900 CFS. So we could look into maybe expanding that to something bigger. Or new infrastructure would be if we see there's really good areas for recharge, but the existing system just doesn't reach those areas. Maybe we can build something out to those areas to get some water out there. That's kind of some of the concepts for the level 3 infrastructure. And then within each level, we're looking at 3 scenarios. We do kind of a bookend scenario, something small, something big, and then something that we call intermediate in between. So we'll have about 9 FloodMAR scenarios once we're all done.
Thanks, David. We have a few questions on the climate change analysis. As you indicated, it would be great to probably have another session dedicated to climate change. But would you mind spending a moment or two talking about the future climate inputs? Are we making daily 100-year weather forecasts for temperature, precip, snow? If not, how do we get there? Are we incorporating GCM outputs like precipitation and stream flow in the recharge? And are we treating, are we using a perfectly known forecast in our assumptions?
A lot of questions.
That was a lot of questions. Sorry, I lumped them all together.
Is Romain, are you on? Because Romain always does a much better job talking about the climate change analysis than I do. He lives and breathes this. So I'm wondering if Romain is still on, if he can give like just like a 5-minute spiel and then do a much bigger talk on it in the future.
Yeah, I'm here, David.
Awesome. Thanks,
Can you
man.
guys hear me?
Yep.
Yeah, I think I definitely need to provide a presentation at another session. But I think the overall idea here is we are not using directly the general circulation model and downscale them at the grid cell level. So we are using a different procedure, which is called like a decision scaling or bottom-up approach, which is really trying to take the historical pattern of the climates that we have observed and perturb it, in this case, obviously by 10, from minus 20% to plus 30% of change in precipitation on an annual base, and from 0 to 4 degrees Celsius increase. So let's say that you have a, the current condition here, which is at 0, 0, you're going to have 100 years of hourly precipitation and temperature reconstructed from the Paleolithic information. For the last 100 years, we have most of this information in general, and for each sequence or each of these data, we modified the overall annual change. So it's really like a shift in your hydrology. I think for a planning exercise, is really like more a sensitivity analysis to see how far the system, how resilient the system is to future conditions. The next step that David didn't show is that you can relate this surface response on these data to GCM and show like, how they distribute in his platform. And that's one way to go at it. There is also, like, we are working on the Trelawney watershed study with using similar procedure with the weather generator, where we accounting for more complex effect of the climate, especially on the thermodynamic aspect. But again, I don't want to get too much in details without graphics and explanation. It's just get very complex.
Thanks, Romain. That's a good overview. Yeah.
Yeah, thanks, Romain. And now you've whet people's appetite for an upcoming climate change discussion. So on the multi-benefit side, how do we include things like floodplain expansion and recharge in this analysis?
Can you say that again? Sorry.
How do we consider floodplain expansion in the analysis?
I see that's from you. That would be within our level 3. We're thinking of working it into there as expanded infrastructure. So we would look into, doing some floodplain expansion and flooding some floodplains and getting some recharge for that. And it's funny that Aisha asked that, because we are working with American Rivers on that. We haven't gotten very far because we've been focused on just baseline level 1 so far. But the idea would be, let me bring it up here. Here we go. With our RAS models, we can look into modifying the RAS models to do floodplain flooding and reconnect the floodplains with the river, and then kind of figure out a way to maybe pull that information out for recharge purposes through the groundwater model. That's kind of what, but we just haven't gotten very far on that, but that is an idea that we're looking at for level 3.
I see Graham in the queue. Hi, Graham.
Hi, can I ask a question?
Of course.
Sorry, I forgot to figure out how to raise my hand, but anyway. Great presentation, David. I think this is sure to become a classic study and a very comprehensive one. One of the criticisms of LunchMAR is that there's many, many moving parts, and you have to get lots of integrated watershed management coordination to ever pull it off. You've got surface water management, groundwater management, land use, and lots of other requirements. And some people will say that therefore it will never happen because it's too complicated, right? Which I disagree with, but what are your thoughts to the extent that you can broach them right now about where you see this going in terms of the response of the partners in the watershed to doing something about it in the future?
Well, I'll talk about MID a little bit. And I think I saw Marco Bell from MID in the chat window, so he can always jump in and correct me if I'm wrong here. But I think when we first approached MID, they were pretty skeptical of this idea of FloodMAR, of what we were trying to do, but they gave us the benefit of the doubt and decided to work with us. And I think they're at the point now where they are believers in FloodMAR already. We haven't even finished our study, but we've shown them what we've done. We've shown them the potential, I think, through some of the preliminary modeling. And I think they're moving forward with trying to implement their own FloodMAR projects. And I think they're very interested in moving forward with us on pilots. So I think that's kind of, well, hopefully what comes out of this study is, the numbers won't be exact. And yeah, there's gaps in their models and there's gaps in the data. It's not perfect, never is. But like I said at the beginning, it's a proof of concept. And I think we're proving that at least the concept, yeah, it's hard to implement. There's a lot of moving pieces and everything you just said, Graham, but it's worth doing. There definitely is a lot of potential. And I think that's what our study is showing. There is a lot of potential. People are getting interested, people want to do it. And hopefully the models that we're putting out there are at least a place that other people can start, that not everyone else has to start at square one like we did with the study, that at least they have something to get them going, and to kind of get them moving a little bit faster on looking at their own FloodMAR projects. I'm not sure if that totally answers your question, but I guess.
Oh yeah, no, I think a key is that MID is there and now they're interested, and they're a big partner or a big influencer and manager in the basin. So that's probably really key.
And I just saw Marco Bell raise his hand, so hopefully he agrees with what I said, I hope. I don't know if Marco, if you're on there, if you want to talk. Or maybe he's in the chat.
Maybe he's still muted.
Yeah, he's been participating in the chat. Maybe he's muted.
It doesn't look like Marco is muted. He should be able to speak. Let's try.
All right.
I think Matt Beeman is also from MID. I think he might also be on. I don't know if Marco, Matt, if you guys want to say anything.
Hi, Dave. Can you hear me?
Yep.
All right, cool. Hi. Yeah, so hopefully Marco is able to unmute and jump in. He's welcome to anytime. But I know that we're very excited about the opportunities through FloodMAR and looking at it on a basin-wide scale, not just MID. But it's a very promising study, and we're looking forward to implementing in the future.
Well, there we go. Thanks, Matt.
Yeah, no problem.
All right, we just have a few minutes left. I would invite anyone to add any remaining questions in the chat, and I can work with David and the team to get them answered for you. Thanks for participating. David, thanks for your great presentation. I think it spurred a lot of ideas for continuing this conversation through this webinar series. I would like to invite people at this time to use their reactions button to give David a virtual high five, applause, or thumbs up. Thanks for participating. And I just want to say, I looked at the participants list. I think at the peak we had, I like your snaps, Mike. I think we had over 100 participants, and when I cruised through the list, I'm really inspired by the venue we've created here. A lot of different perspectives represented. true integrated water management participants. I think I saw over 10 DWR programs represented. We had other state agencies like the Water Board, the Flood Board, CDFW, Delta Stewardship Council, a lot of local agencies, NGOs, academia, consultants. If we can just keep growing this list and continuing this integrated conversation, I'm really excited about what this forum provides us. And just to give folks a heads up, for September, we have lined up Will Logan with the Army Corps of Engineers Institute of Water Resources to talk about managed aquifer recharge in the Corps. We have listened and noticed that we've got very few, if zero, participants from federal agencies that participate in our LunchMAR, so we're hoping that this gives a good jump start. And for October, we have Maurice Hall from Environmental Defense Fund to talk about multi-benefit groundwater recharge for resilience. So really great future LunchMARs to keep our momentum going. This has been a great forum. It's 1:30, and thanks again for joining us. We'll see you next month.